We are asked to determine the slope of a line. The slope of a line is simply the tilt or the angle of the line. The slope is a fraction, which can also be called a ratio. Let's go to the diagram to the right to discuss rise and run. The slope consists of the rise and the run. The rise represents this vertical line, and in this case, from this point to this point, which is 3 spaces on our graph. The run describes the movement going side to side on the graph, also known as horizontal movement, and in this case goes from this point to this point, which is a value of 2 spaces on the graph. You will see that this pattern continues to go up 3 and over 2. Rise 3, run 2. Therefore, we describe the slope of this line as a 3 over 2, and the 3 represents how much change occurred in the y-axis from point to point, and the 2 represents the amount of change in the x-axis from point to point. So the slope is made up of a series of triangles that are all the same size and all the same ratio, which is 3 over 2. You can find the triangles underneath the line too. It goes over 2 and up 3, and over 2 and up 3, and over 2 and up 3, which is basically the rise and run found on the underside of the line. But it is the exact same triangle. So slope is described by the code letter M, is basically the change from y value to y value over the change in x value to x value, and the y change is known as the rise, and the x value change is known as the run. There is a bigger picture here which you should know. Slope can also be described as the rate of change, which is a speed. Every graph of slope is really telling you a story. Let's look at this graph and describe the slope as the speed at which a snail is moving. We could label the x-axis minutes and the y-axis inches. So this graph would be describing a snail, let's say. This is my story, you can make up yours. That is traveling or moving at a rate of speed. For every 2 minutes, they move 3 inches. And notice that this continues from point to point with the same 2 minutes and 3 inches. So the snail is moving at a constant rate of change or speed of 3 inches in 2 minutes. Because the rate is constant, it will draw out as a straight line when you have a constant rate of change. Hold on and retain that thought. Let's talk about the types of slopes. Let's look at this one first. This type of slope going in this direction is known as a positive slope because it goes in this direction. So I draw a picture with an exaggerated V to show you that it goes in this direction. If it doesn't go in that direction, then it must be the opposite of that, which is a negative slope. This slope is known as a zero slope. And I exaggerate the z in this way to help me memorize zero slope. This slope is described as no slope, so I emphasize the n in this manner to help me memorize no slope. No slope is also called undefined. Let's try a couple examples. To name the m, or the slope, we merely have to count off one of the triangles that we see. I recommend you draw it and then color it in so you can see the triangle. This one has a rise of 2 because it goes up 2 from here to here, and a run of 1 because it goes 1 from left to right on the x-axis. So the slope is called 2 over 1, or you can call it a 2. And it's positive. This slope goes from here to here, or it rises 3. And it runs from here to here, which is 4. So this slope is 3 over 4. And I recommend you color it in so you can clearly see the 3 over 4. Now it is your turn to tell me the slope of these two. This one has a rise of 2 and a run of 4, which gives us a 2 over 4. But this must be simplified as all fractions into 1/2. This one has a rise of 3 and a run of 4. But I hope you did not forget to say that it's a negative 3 over 4. And now you know the slope triangle.